So this is lesson number 2, water crisis in India. So before we begin this lecture, in my previous lesson, we talked about briefly about introduction about India. And then we also talked how water is related to those major issues or challenges India is currently facing. And I gave you 3 statistics. One is that 600 million Indians, they still live under high and extreme water stress condition. And I'm going to explain to you in this lesson what is the meaning of water stress condition. 2 lakhs or approximately 200,000 people, they die annually due to lack of access to clean water. And then demand for the water is going to be 2 times higher than supply by year 2000, by year 2030. And the impact is going to be severe. It's going to impact India's GDP, and the GDP loss is been predicted by 6%. Okay, and then, like I always say, is that the reason we are talking today because our goal here is Next Generation Nations, or NGN, is to solve this problem once and for all. So this is goal number 2, which is guarantee access to safe drinking water and modern sanitation for all. This is not just India, just globally. Second thing I want to talk about, that I do use OneNote, that's Microsoft OneNote, so that students can, and by the end of this lecture, this entire lessons, when I'm done with explaining water crisis in India, I will provide this OneNote so that teachers and students, they can share and interact. Okay, so let's just begin our lesson number 2. Again, before we jump into water crisis in India, I just want to talk about very simple facts that where is Earth's water? And you may have seen this before, but bear with me. So here, there are 3 graphs, 3 bar graphs. On your left, what you see here, here is a global, but on high level, you can see that 96.5% it's ocean water, and only 2.5% that's the fresh water. And this 2.5% water is good enough for life to survive. Okay. Now, out of this 2.5%, let's just walk over to the middle graph. And this is the breakup of fresh water. Approximately 69%, it's in the form of glaciers and ice caps. And approximately 30% is in groundwater. And then rest of 1.2% is surface or other fresh water. And this is when the meaning of fresh water is that you have rivers, dams, rivers, farms, lakes. Those are the surface waters. And then with this surface water, again, still 69% is captured with the ground ice, and lakes consist of approximately 21%. So the point here is that the world is surviving with this 2.5% fresh water, and out of 2.5% fresh water, we have only 1.2% fresh water. It's very important for students to understand where the water is coming from, and then this may give you for the next generation, this may give you a better idea how to solve this water scarcity, not only in India, but all over the world. Let's just move on to the next one. Now, this is very interesting. What you see right now, so usually when you imagine Earth, or when you look at the Earth, you see a blue Earth, right? Because blue oceans, right? Now, you don't see oceans here. So what this image suggests that all the waters from Earth, oceans, ice caps, lakes, rivers, groundwater, everything is being collected or captured. And if you do that, approximately what you see here on your left hand side, let's see if I can draw this. This is approximately 860 miles. Okay, that's the entire global water. That includes your body water also. Okay, again, don't go by the detailed numbers, but just say this is approximately numbers. Okay. Someday I will learn how to write properly. The second sphere, what you see here, that represents a fresh liquid water. That's approximately 170 miles in diameter. Again, we are talking about spheres. And believe it or not, there is a third sphere here. I don't know how sharp your eyes is, but it took me some time to figure it out. So this tiny, tiny, tiny one, yeah, that represents the rivers and lakes. That's only 39 miles diameter sphere. So there you go. What I presented, what's been presented here is that the global water views right now. Okay. So again, the point here is that you can see that most of the waters on Earth, more than like 95, 96%, it's not been used. I mean, there are many things you can use it, but that's oceans, ocean waters. When I say it's not been used, I'm just talking strictly about for agriculture, drinking water, and industry. I mean, there are many efforts that have been going on right now. How do we use? One of the biggest effort is the desalinations, and Israel is very big on that. So that's something we're going to talk in solutions. How do we solve this water scarcity issue? So this ocean is going to play ocean could be used as one of the resources to solve water crisis all over the world. Okay. Again, we are still talking about water crisis in India, but it's very important for me to talk about the science behind this. Okay. Now, this is my favorite. What you see here is that it's a very simple. It's been used for all. This picture has been used to explain the kids, but I think we can use this for our lesson. That the sun that makes this water cycle. So what happens is that when the ocean water gets heated, it gets evaporated. Okay, the water, it's called as a water vapor. The water vapor, it just gets evaporated and it just climbs up, and on when it goes high, where the air is cooler. Now the water vapors, it condenses into the clouds. Okay, and then this cloud is being drifted or moved by air. Okay, you must have seen clouds are moving. That's because the air current. And then water drops in the form of from the clouds. That it's in the form of either snow or rain. And once this snow it melts, it flows to the rivers, and then the water also goes to the groundwater. I mean, that's called as groundwater recharging, right? I mean, India has many of those groundwater resources. And again, I'm not talking about just this groundwater has been recharged by rain also. Okay, most of the water from India has been recharged from both sides, from snow, from Himalayas, and then also from rain. So, and then some of the water it goes back to ocean. So this entire cycle, what you see here. So sometime the next time when you see raindrops, you may think, oh, these are the fresh new raindrops, but that may not be true. That may be the recycle, which the raindrop may be recycled because it may come from oceans and goes to a cloud, and then it comes back in the form of snow or ice, snow or rain. Okay. So again, this is just a recap of science behind the water. Okay. Now, the last thing I want to talk about this, again, this is all about research, okay? And I do want to focus on NITI Aayog report. I did mention about that this is a fantastic report in terms of data. It gives you a lot of information about which state outperform and which state did not perform at all. And it provides a baseline. So the simple way, there's one thing I want to talk about here is that composite water management index. So what I was going to say that the simple way to describe this composite water index, I'm going to explain to you that let's say you have a classroom, okay, and in classroom you got 29 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So total 29 students. Okay. And I'm going to call this as a class of, let's say, 11B. Okay. Now, if you want to find out what's the class average, the performance wise, how do you tell that? If you want to find out how is student A is performing against, let's say, student B. And I'm sure that all of you have gone through all of you have climbed up your ladder and passed from grade 1 to wherever you are right now. So that could be multiple answer, but I'm going to let's just prepare a simple answer here that if I want to understand the performance of class or performance of students, I'm going to say that, look, the first thing is going to be that I'm going to take exams, written exams, and that written exam, it has weight or points. I'm going to put down this as activities. And this exams, it has a points of, let's say, 50 points. Okay. Then you have physical exams, PE. That has, let's say, 20 points. And then you have a project. You need to present a project or put together some kind of demo, let's say 30 points. It's very simple. I'm just trying to explain to you. So now each student must finish these 3 activities, and then by the end of year you should be able to say that, look, how did each student perform against each other. And once you have student grading, you can just say that how did this class 11B perform against, let's say, 11A or 11C if there is a big class. And then you can come up with a kind of a composite index for the class 11B. Okay, so this is pretty much this NITI Aayog report. What they did here is that there are 29 states in India, and then they came up with composite water management index, and that index, and I'm going to explain to you later on, that tells you that what are the points, what are the weights, and what are the activities. They call it as a theme. And then after that, they just try to compare these states against each other. Okay, so this is what I'm going to conclude my lesson on research, and because I want to jump on quickly to causes, and that's going to be very fantastic. Now we are going to talk about mainly about water scarcity in India. Okay, stay tuned.